for class 9 student. For class 9 student, this is motion along a straight line. ST, motion along a straight line. This is for class 9 student science. Here see motion, rest and motion. It is little bit difficult to explain rest or motion. Suppose an object in your book on a table, book on a table, a book on a table is a book on a table, uh, book on a table is, or you can say that a book kept on a table is at rest. A book kept on a table is at rest. This is at rest because the because the observer because the observer he finds that with respect to time the book does not changes its position, because the observer finds that the book does not change its position does not change its position with respect to time, with respect to time, as well as with respect to ground. A book kept on a table is at rest because the observer finds that the book does not change its position with respect to time as well as with respect to ground. But when the same book when the same book is viewed when the same book is observed from moon, the book is in motion because the earth is in motion. So it is rather difficult to at your level it is rather difficult to explain the term rest or motion, because you see a book kept on a table is at rest because the observer finds that the book does not changes its position with respect to time as well as with respect to ground. But when the same book is observed from moon, the book is in motion because the earth is in motion. So mm, there is no term, so there is no term like absolute absolute rest or absolute motion. But at your level but at your level, uh, I can say that but at your level I can say that if an object does not changes its position with respect to time, as observed by an observer, we can say that the object is at rest. Similarly, if an object changes its position with respect to time as observed by an observer, uh, we can say that the object is at motion. Now I am going to, that is the distance and displacement. Distance and displacement. Distance, it requires only magnitude. Distance, it requires only magnitude. That is 50 meter, 25 kilometer, etc. So we can define distance as the total path length covered by an object is called the distance covered by an object. The total path length covered by an object is called the total path length covered by an object is called the distance covered by an object. Now, uh, uh, displacement it requires both direction and magnitude. So we can define displacement as the shortest distance measured from the initial to the final position of an object is known as displacement. So uh, so as the motion is in a straight line, if uh, let let an object moves in a straight line moves in a straight line, that is from A to B, in a straight line from A to B. It starts, this is the initial position and this is the final position. So let this be 5 meters. So here magnitude of distance is the same as the magnitude of displacement. That means let an object moves in a straight line, that is from A to B. This is the initial position and this is the final position. So here 5 meters. So in this case the magnitude of distance is the same as the magnitude of displacement. Now I am going to this um, uh, this uniform motion and non-uniform motion. Uniform motion, we can define that uniform motion we can define if an object covers equal distances in equal interval of time, it is said to be in uniform motion. That is, if an object covers equal distances in equal interval of time, it is said to be in uniform motion. That means, let me explain you this: A, B, C, D, E. This is 5 meter, 5 meter, 5 meter, 5 meter, and time taken is 1 second, 1 second, 1 second, 1 second. Then if it covers 5 meter in 1 second, again 5 meter in 1 second, 5 minutes, then we can say that the body is in uniform motion. Now non-uniform motion, this we can define it as if an object covers unequal distances in equal interval of time, the object is in non-uniform motion. That means, suppose an object moves from A to E, unequal distances. Suppose this is 5 meter, then this is suppose 6 meter, and then again this 3 meter, and then this is suppose 7 meter. Time taken in equal interval, 1 second, 1 second, 1 second, 1 second, 1 second. Then we say that it is in non-uniform motion. Now I am going to, that is your speed. Speed. Actually, this is the speed. We can say that it is, what is speed? We can say that rate of change, rate of motion. That we can say that speed. We can say that it is rate of. We can say that rate of motion of an object uh, uh, rate of motion of an object, we can say speed. What is speed? That is the rate of motion of an object. And rate of motion of object, that is what is rate of speed, we can say rate of motion of an object. That is, what is it? That is the distance traveled, that is the distance traveled by the object in unit unit time. That is the distance traveled by an object. Speed, it is the rate of motion of an object, that is the distance traveled by an object in unit time. But what actually happens that, practically what actually happens that, in most cases what we find that objects are in non-uniform motion, motion. Therefore, to describe to describe the rate of motion, of an object, of of such object, let me such a, of such objects. um, Therefore, to describe the rate of motion of such objects, we require average speed. That is, in most cases objects are in non-uniform motion. Therefore, to describe the rate of motion of such objects, we require average speed. So average speed is equal to average speed average speed, this is equal to total distance traveled by total time taken. Therefore, and another important point is, for speed, to um, specify the speed of an object, we require magnitude. Now this is all about speed, and this is all about speed. Mm. Now I'm going to velocity, that is velocity. Direction of an object direction of an object along with speed is called velocity. Hmm. Therefore, velocity is the speed. It is the speed of an object. Moving. It is the speed of an object moving in a definite direction. It is the speed of an object moving in a definite object. Therefore, velocity of an object can change by changing the object's speed, direction of motion, or both. Now, uh, now I am going to explain, that is, uh, this is very important. That is, when an object is moving along a straight line, when an object is moving in a straight line at a variable speed, we can express the magnitude of its rate of motion in terms of average velocity. It is calculated in the same way as we calculate average speed. This is very important. If the object is moving along a straight line at a variable speed, we can express the magnitude of its rate of motion in terms of average velocity. It is calculated in the same way as we calculate average speed. But in case of but uh, in case of um, in case of in case the velocity of the object is changing at a uniform rate, the average velocity is equal to initial velocity plus final velocity divided by 2. The u is the initial velocity, this is the initial velocity, and v, it is the final velocity. Now I am going to the last topic, that is acceleration. Acceleration, it is the rate of change of velocity. For uniform motion means your velocity is constant. Uniform motion of an object velocity is constant. Therefore your acceleration is 0. And for non-uniform motion of an object, your acceleration is equal to v minus u by t. Final velocity minus initial velocity divided by time taken. Now an object traveling in a straight line, if velocity increases or decreases by equal amount, by equal by equal amounts in equal interval of time, in equal interval of time, then the acceleration of the object is said to be uniform, and non-uniform, that is for non-uniform it will be that means the motion must be in a straight line, same statement, an object traveling in a straight line, if velocity increases or decreases by unequal amount in equal interval of time, then the acceleration is of the object is said to be non-uniform. That is the definition. Now the most important is very important, that is important is the motion of a free falling body. Motion of a free falling body is an example of uniform acceleration. Now your last topic, I am going to show only the graphs. I am going to show only the graph, that is distance time graph. Distance time graph. This is time and this is distance. Straight for uniform speed. This is uniform speed. Now again distance time graph. Time, distance. This is non-uniform speed. And now I am going to this velocity time graph. Velocity time graph, that is here. Velocity time means velocity is constant. This is uniform motion, that means velocity is constant. Uniform motion. Again velocity time graph. This is velocity time graph for uniform acceleration. And one important thing is, in this area under the curve gives the distance traveled by the object.